Hi, this is Mrs. Jackson. This is Chapter 1, Section 1, Part 5, and in this video we're going to talk about key features of functions and their graphs. We've got 10 terms here listed. We're going to talk about the definition of each of those terms, and I have an example graph here, function graph, and we'll go ahead and write in set notation and interval notation the specific numbers for each of the features of this graph. Okay, so the first thing is domain. So the domain is the collection of all inputs, and that means the collection of all x values. And likewise, the range is the collection of all outputs, or the collection of all y values. Okay, so if we look up here in our graph, the first thing, I'm going to zoom in here, the first thing I want you to notice is that it is terminating on both ends of the function graph, and these points are closed. They could have easily been open, but you do have to look to see whether that point is open or closed. Okay, so closed, remember, is equal to in terms of our inequality statements. Okay, so in terms of our domain, collection of all x values, our graph starts on a minimum side from -1 and goes up to +6, closed on both ends. So from a set perspective, we have the set of all values of x, so the set of all values of x, such that x is less than or equal to 6 and greater than or equal to -1. And from an interval notation perspective, our minimum is -1, our maximum is +6, and we're closed on both ends, as shown using the brackets. From the range perspective, that's the set of all outputs. So our minimum here output is y equals -12, and our maximum output is y equals 4. The -12 is closed, and the 4 is also closed. We can touch that on the graph. So from an interval perspective, we've got the set of all values of y such that y is less than or equal to 4 and greater than or equal to -12. And from an interval notation perspective, our minimum is -12 and our maximum is +4, and we're closed on both ends as shown using the brackets. The next two terms, increasing and decreasing intervals, is the portion of the graph where you either have a positive slope, rising, or a negative slope, falling. And as in the case with all intervals, we use the domain, the x values, to describe that part of the graph, except for the range. That's the only exception. So the increasing interval is the x values, the set of x values, where the output is rising, and that is shown using a positive slope. Maybe put that in parentheses here. And likewise, the decreasing is where the x values are yielding a falling output, or where the output is decreasing, let's say. And that is indicated by a negative slope. Okay, so when we're talking about slope, we're talking about left to right. So if you're climbing a hill going left to right, so you're going up here, that would be a portion of the function that has an increasing interval. Whereas if you start at the top of the hill here and left to right, you find yourself going down the hill, that's a decreasing slope. So our increasing interval is always described using the x values. So we have an increasing interval beginning at -1, and it's ending at the peak here. We call that the vertex at x equals 3. So we're going to describe it using the x values. Now, one point to note here is that when we're talking about increasing, when you're at the bottom of the hill here, you are neither increasing or decreasing. You're at rest. Same thing with at the top of the hill here. You're neither increasing nor decreasing. You're at rest. Think of it as neutral. And so when we're talking about increasing or decreasing intervals, the ends are always going to be considered open. Same here on the decreasing interval. We're at rest at 3, and then we are at rest at x equals 7. Okay, so in set notation, we have the set of all values x such that x is less than 3 and greater than -1. And from a decreasing, we have all the set of all x values such that x is greater than 3 and less than 6. And so in interval notation, all the endpoints are going to be parentheses since they're considered open. So we have a -1 min to +3 and a +3 up to 6. Okay, the next two terms, positive and negative interval, are easy to get confused with increasing and decreasing. But the positive interval is the x values where yielding an output that is positive or greater than 0. And the negative interval are those x values yielding an output that is negative or less than 0. So x values where the output is greater than 0, and x values where the output is less than 0. Okay, so if we look at our function, this is the 0 line here, y equals 0 line, the x-axis. So our function is greater than 0 between inputs 1 and 5. Now, just like the increasing and decreasing at the endpoints here, at x equals 1, the output is 0. That's neutral. That's not positive nor negative. So we would consider this endpoint being open. Likewise, at x equals 5, the output is 0, which is neither positive nor negative. So we're going to be parentheses or open on either side. So for the positive interval, we have the set of x values such that x is less than 5 and greater than 1. And in interval notation, our minimum is 1, our maximum is 5, and we're open on either end. Okay, when we look at negative intervals, we actually are going to have to describe 2. So sometimes it's easy to use an index card or another piece of paper to kind of cover up the curve, if you will. So if I just drew a box and just looked at where this function is below the 0 line, you can easily see that there's 2 intervals that we have to describe here. So the first one, we always describe the left one first, begins at an x value of -1 and ends at an x value of +1. Just like the positive interval, the endpoint here would be considered open because at x equals 1, the output is 0, which is neither positive nor negative. However, at x equals -1, our output is -12. It's clearly negative. So this endpoint here is considered closed. Okay? So our left interval we're going to describe as the set of x values such that x is less than 1 or greater than or equal to -1. And from interval perspective, we are a bracket at -1 and an open at +1. The second interval starts at x equals 5 and ends at x equals 6. Now at x equals 5, the output is 0, neither positive nor negative. So at x equals 5, we would consider that an open. But at x equals 6, the output is clearly negative at negative 5. So that would be considered closed. So the second interval is the set of all values of x such that x is less than or equal to 6 and greater than 5. And in interval, we're going to have a minimum of 5, a maximum of 6. We can be equal to 6, so we're going to use a bracket, and the 5 is open. Okay, so before we move on to the final 4 terms, I just want to point out that all of these terms above here are sets of numbers. So it's worthwhile to make a note of that. All of these are sets, intervals. And it's probably worth noting that all of them are x values except for that one on the range. So you might want to make a little note here that the range has the only one that uses a y variable. Okay, the remaining terms are not sets of numbers. They're actually single value, or we could call them points on the graph. And the first two are the intercepts. So the y-intercept is where the graph crosses the y-axis. And you're pretty familiar with that term. And it's a point. So on our graph, we are crossing the y-axis at y equals negative 5. It's worth noting that there's only ever going to be one y-intercept. And that is because if we had two, it wouldn't be a function at all. You cannot have two outputs for a given input. So it's important to know that you're only ever going to have one y-intercept. You could write that intercept as y equals negative 5, but please don't write just negative 5. You do need to note what variable we're talking about. Or some people describe that as a point, so that the definition of an intercept, y-intercept that is, would be at x equals 0, so you could write 0, comma, negative 5. And the x-intercept is where the function crosses the x-axis, and it's important to note that we could have no x-intercept. We could have one, or we could have many. So it's important to know that. On our graph, we happen to have 2. So we have x equals 1 and x equals 5. Our textbook calls these the zeros. And other textbooks may refer to the x-intercepts as the roots. So all 3 terms is something that you need to know: x-intercepts, zeros, and roots. So I'm going to go ahead and write that in red here. Zeros or roots, all 3 terms you really should know. So write down x equals 1, x equals 5, or you could write those both as points, 1, 0, or 5, 0. And the last 2 terms, maximum and minimum, refer to the output. So the maximum is where the output is largest, and the minimum is where the output is the smallest. Okay, so they are also points. You could refer them to points if you wanted to. Usually we just use a value. So our maximum would be here on the vertex. Our output is 4. And our minimum from an output perspective is negative 12. That's the minimum and maximum that you would use to describe your range here. So we've got y equals 4 as our maximum, and y equals negative 12 as our minimum. Okay, so these are 10 features that we could use to describe any function, and you are going to need to know all of these terms, so please study them or make index cards for these, as we will be using all of these terms for the rest of the year. Okay, hope this video helps.